Good morning, good afternoon, everyone. I hope everyone is doing okay and ready for another week. I really appreciate you all being with us for so long. I know it's been complicated, like every Saturday waking up early and attending session, but I appreciate you spending time with us. As a startup activity, let me know which service is your favorite in AWS. Where, if you have to pick up one service and play around with it, what service it could be, and give me a little more rational, like, okay, instead of name, it is name, but what I like about that service. So let me know what you feel is your preferred service in AWS, and little bit about like a one liner why that service is so interesting to you. Lambda, okay, I was expecting EKS. Oh, that's a good choice. It's complicated, but yeah, interesting. Comprehend, I like it. Comprehend can save a lot of manual work. ECS, again, a near service, is like that's true. ECS helps you in maintaining and orchestrating your container. S3 almost in every architecture. I won't deny that, Asna, because everything you do has to be stored somewhere, and that is where S3 comes in. Amazon Lex, interesting service. Cloud Formation, oh, nice. Okay, good. Somebody is liking the thumbnails. Yeah, I try to be a little creative sometimes, and that's what the result is. But yeah, all credit to Tom Cruise and Emily Blunt. This is what they have done. It was a beautiful movie. Hopefully, everyone remembers it. And I tried to be a little creative here. If you read the movie title, it says live, die, and repeat. I tried to put it here: run, no, maintain, and repeat. So you run and repeat. That's what we are trying to do today. It's about serverless. So hopefully everyone would enjoy and learn. Bedrock. Bedrock is interesting service too, Siddharth. VPC, I like it because it is all network. Without it, you would not be able to move forward. IAM, yep, control on that, agree on that. S3, for me, it is also S3 and Lambda. I have to always be choosy in what I say first. But yeah, these two services are really, really useful because anything you do, you have to store it somewhere, and S3 made it so easy. You just need an API call and you can go ahead and get started with it. And if you haven't checked, check S3 Express one zone. S3 has come up with a new type of bucket which we call directory bucket. Really interesting use case, really, really fast, and it can be very useful for a lot of machine learning inferences. So check that too. Lambda, obviously, because it can do lots of things. I call Lambda as a Swiss Army knife of AWS because it can do so many things, and today we will be discussing that service. Thank you so much, and let me add now everyone onto the stage so that we could just say hi, and then we would be moving forward. I'm adding Richard. You could see some 10. He was on holidays, so hopefully he enjoyed things. Parna, thank you. Prasad, and we have Kapil. So everyone, we are here, and Parna and I would conduct the main track today, and then Kapil would talk about some question answer, and Prasad and Richard are answering, and Kapil is also answering questions. So keep your questions coming, and we will quickly get started. Thank you, Parna. Let me add your slide deck, and then we will get started. I'll remove others from the screen, and we will speak to you again. Thank you. So today we wanted to talk about serverless. So I want to be a customer, not a tricky customer. I would be very a genuine customer and will not be giving you a hard time. So I want to understand, Parna, like what is this serverless all about? Why we talk everyone talks about serverless. Everyone says it's amazing. I have no clue about it. So if you could help me in layman's term, what is serverless? Is there no server at all? Everything runs from air? What it is? Uh, Parna, I think we lost you. Not sure if disconnect happened. Can anyone hear her? I can't. Okay, let me try adding her to stage again. Give us a few seconds and probably we would be talking about what serverless is. But when I hear about serverless, everyone just focuses on that Lambda function. That is not true. Lambda is one of the way of running the services, but there are many other options available too who would help you to run things into serverless fashion. And serverless doesn't mean servers are not there. If I had to put a definition again, I would have said server maintenance less servers, that is what I would call serverless, because servers are still there but you are not maintaining it on your own, and that makes your life easier and you still get the functionality you are looking for. It could be okay. I am uh, having some difficulty. Can you hear me or no? Can you hear Ashish? Parna had to drop off and she would come back. Let me add others also. Richard,
Yeah, I can hear you,
Sad,
Ash.
Yeah, we
you
can
can hear
hear.
me?
Yeah.
Okay, good. So probably she would join in soon time. Otherwise, you would be left with me, and I would bore you with my funny things. So let's start. Means serverless idea is that we want to ensure you get what you need rather than focusing on the back end of that. So serverless is a method of delivering your services. It is not one single service, because most of the time when customer talk about serverless, they may have an impression that it is just the Lambda function we are talking about, but it is not just the Lambda. Let me add Parna back to stage. Parna,
Okay. Sorry about that.
that
Things
is
failed
okay.
in
That
IT.
happens.
All
Okay.
right. So,
You have to share your screen, Parna, and we will get
yeah,
started.
yeah.
I was trying to just keep them engaged, but obviously I can't do better job than you, so I will let you handle
Just,
things.
yeah, just give me a minute.
Yep. And just an announcement while Parna is sharing screen, that we would be having our um, group mentoring session, which is part of Cloud Career Journey, today afternoon. So some of you would be seeing us again, me and Prasad. So thanks for that. If you want to know more what the group mentoring is, we would be happy to to explain that. Shouldn't be an issue. Let me add screen again. So yes, Parna, let's move forward with what is serverless. Not why.
So,
Let me just give me example. What is serverless? Why I would come to backlog. So if you have to
sure.
say what is serverless, how you would explain it to me?
All right. So, I hope you can hear me and see me as well as see the screen share.
Yep.
All good? Okay. All right. So, firstly, why serverless, and why most of the customers ask, why would I move from the traditional way of doing things, right? So, firstly, as you know, serverless doesn't really mean that there is no servers. It is just that there are servers which are managed by AWS. You are not really going to be configuring and administrating those servers. Okay. You are going to be focusing only on what matters to you most. So, as developers, life is really easy, zero administration, right? So you are going to be focusing on building your application, optimizing your application, and that's all you're going to do. No infrastructure management. Secondly, automatic scaling. So imagine if you would be deploying your applications on EC2, you have to think about scalability, right? Maybe you're starting off small, but over a period of time, your company might grow, your audience might grow. You'll have to make a workload which scales seamlessly, handle peak loads. Okay, so for that you'll have to probably make use of load balancers, auto scaling groups, etc. However, in case of serverless, the scaling is automatic. So you inherit those privileges of automatic scaling as soon as you adopt serverless architectures, right? So that's a great advantage. You don't have to manage them yourself. Pay for value, meaning you pay for only what you use. Now imagine a EC2 instance which is running 24 hours a day, right? You are using it for, say, testing, Ashish, or you are using it for some POC. So as long as that server is running, you're going to be paying for it by the second, by the hour, right? You may not be using it. Your developers must have just left it lying around. However, in case of serverless, say a Lambda, only when you're invoking it and it's running, that's when you pay for that invocation. So you pay for that use only for the resources when you're using it, not when you're actually running those infrastructure. So that's a great value that you get. And inherently, these serverless products are highly available and secure. Okay, so you don't have to think about the security of the infrastructure on which, say, Lambda is running, or your API gateway, or your DynamoDB. Your data also, for example, in DynamoDB, as they are encrypted at rest. Okay, so automatically that's done for you. There are multiple copies of your data, so they are highly available across within that region as well. Okay, so these are some of the great benefits that you can get and why you would move to serverless. I hope that answers that.
Yeah, I have a follow-up question on that, Parna. So I
Yeah.
understand what a serverless is, that I'm not maintaining those servers. So how it differentiate from a fully managed service? Because AWS has fully managed services,
Hmm.
and then there is a serverless. So aren't they same thing? If I'm not managing, is it the only benefit I'm getting?
So just think of it as, if you're managing the infrastructure, you'll have to actually do the patching as well as maintenance as well, right? Even the operating system level maintenance, any kind of firewalls or host firewalls that you're going to be putting, everything is your responsibility, right? If you know about the shared responsibility model, when you opt for serverless, that division between what the security in the cloud, security of the cloud, it's moving a little upwards. So basically, AWS is taking more of the responsibility for you, right? So it's reducing the overhead on you. Hope that helps.
No, I'm still not clear. So let's say if I
Okay.
talk about example of ECS as a fully managed service. So
Okay.
how it is different from serverless? Isn't it the same thing? ECS, would you call ECS serverless or no?
So in ECS, there are two types of launch types that we say. So you can have self-managed, where the ECS nodes, which are your EC2 instance, you're going to be patching and managing that infrastructure yourself. Or you can go for Fargate. So that is like the serverless way of running your containerized workloads. So in that case, you are just giving your specification of your resources that you need. You will be providing your containers, images, your task definitions, etc. That's all is your responsibility. But the infrastructure part is not going to be managed by you. That's going to be managed by AWS. So Fargate
Okay.
is the serverless way of doing things. If you choose EC2 launch type, you are going to be managing those container instances.
So let me
Does that make
summarize
sense?
what my understanding is. So if I'm using ECS, yes, AWS helps me in launching the cluster, but I am paying the infrastructure cost. So even my
Yes.
cluster is running, I am not running any workload, I am still paying for it. But if I'm using the same container on Fargate, I
Yeah.
only pay when that container is running. So I get it. So in fully managed service, it could still be that I am paying for the whole infrastructure, whereas serverless, I am only paying when I actually use that component. This is completely pay as you use type of model. Makes sense, makes
Yes.
sense.
Yes.
Great.
Absolutely.
And
All right.
now, should I be using serverless for everything? Is it like a silver bullet which solves all my problem, or you would recommend it for a specific type of workload or a specific type of design architecture? What do you think I should be taking into consideration?
Okay, so there are various uses of serverless. So these are some of the common use cases, as you can see up on my slide. So these are very common ones, like short running workloads that you need. So for example, for IT automation, why I said short running is, for example, if you take Lambda, which is a serverless compute, it has a maximum time limit of 15 minutes. Okay, so that's why I said short running. So any IT automation, say you want to do a security remediation, right? There's something's gone wrong, and as a result, the reaction should be, it should go and say delete some policies. So some IT automation that you want to do, that is a good use case. Any kind of data processing, you mean you want to transform some data, you are streaming in some real time data coming in from logs, application logs, or maybe coming in from IoT sensors, or some click stream, you want to transform them, enrich them, any kind of data processing, again, that's a good use case. That's where you can use it. You can use these days Lambda even as the backend for web applications, or the backend for your mobile application. You can use it that way. And if you've heard about Lambda function URLs, that's becoming popular as well, right? So you can use that. And another very popular use case these days are
I think we lost Purna again. Okay. Hopefully she would join back. I'm really sorry, everyone. I'm not sure because of temperature in India. It's really really high temperature. Probably that could be one issue, but I doubt it. Let's see what if she is able to join back. But I'll try to explain a little bit more on the serverless side. Let me bring my slide deck, and just to give an example that okay, what I treat as serverless option, I would use some analogy. I wanted to present it at the end, but let's use the time so that she can join back. Give me a minute. I would bring that slide deck and we will get started from there. So idea of serverless, again, it's not like a silver bullet. It's not going to solve every problem, but yeah, there can be some specific use cases where you could use serverless as an architecture and you would be able to get the best out of the whatever infrastructure you had to maintain beforehand. So we will focus on those top type of component. Let me bring the slide deck which I wanted to present just little earlier. So give me a minute. Okay, so let me add it to stage and get started from there. So let's talk about some services in real life. It's a very simple example. Probably you would be able to relate to it and in your day-to-day basis. Like let's say we all want to do exercises, right? So we can do exercise, fine, good. And for that, what we need to buy some equipment at home. Maybe I bought a bicycle just for exercise or exercise bike, but I'm now limited to what I can do with that. So what I would prefer, I may go to a gym, take a membership, which gives me access to everything there, and I do not have to buy every single thing. Now I want to do a weight training, maybe I want to do a stress training. I don't have to worry about buying every equipment for me. So that's what I would prefer to go for. And if you look for other things too, let's say you hire a Uber taxi, in that case also you do not maintain anything behind the scene. You just say, hey, I need a taxi, and that taxi would be made available to you. You pay for what you use and you don't worry about anything beyond that. So that could be one example I could think of. Another example, let's say you are using postal services, so you pay for your own letter to go. You do not pay for the whole services. You just pay for the service actually you are using. They may have 10 types of services, but I am using only one. That is also what I could utilize it here. So that is good thing which you could use for serverless. And maybe the next could be, let's say I go to car wash. I don't care like how they source their water or what type of soap they use or how they pay their employee. I go for a service, I get my service done, and that's how I'm worried about only for the value I am adding to myself rather than maintaining the whole infrastructure, right? So it's like if you need a cup of tea now and then, you don't need to own a tea state. Similar type of mentality, like you don't want to maintain the whole infrastructure, you just maintain what you need, and then you can add more services if you need any time. All right, we have Parna back, and thanks for listening me in. Let me add Parna back to stage. Hey Parna.
Just having a bad day today.
That is okay. That's okay. It happens. It happens. Don't worry about it. So and don't stress out. Everyone is here. We are all in friends and family. So don't worry. Don't get stressed at all.
All right. So I'm not sure at what point I got disconnected. So I was
So
telling you
we
about.
talked about web applications, and then I want to understand what could be the use case in machine learning.
Yeah. So in terms of machine learning, so these days when you want to do machine learning inferences, meaning you want to do predictions and you want to query or do prompt engineering, you can actually hit the bedrock endpoints via which you talk to your foundational models or your LLMs, and you can use Lambda for that. So you can build those inference applications on the basis of Lambda. So that's also another very common use case these days. So yes, so hope that answers
Yep, that
your
answers your
query. Yeah.
question. And I heard that uh, Alexa, the devices, I should not talk it
Yes.
loud, otherwise my device would start. So Alexa works completely on Lambda functions, right? Is my understanding
Yes.
correct?
Yes, your understanding is absolutely correct. So when you are asking a question at the back end, actually it is a lambda which is getting triggered, right? So your speech is getting converted to text, then your lambda is doing some kind of analysis to figure out what you said, probably doing some back end processing and then responding back to you. So yes, there is a lambda behind that too.
Okay.
So that's
Now
quite a common. Yes.
yeah, makes
Yeah.
sense. It makes sense. But explain me one thing. Like, is serverless always going to be the cheaper than the on-prem, or sorry, or from the traditional environment, or like a EC2? With Lambda will always be cheaper? Always, always?
Not really. It depends
Okay.
from use case to use case. It's not really always the cheaper option. But if you have intermittent workloads, you don't
Mm-hmm.
need it to be running up and running all day long, for example. That time Lambda could definitely be cheaper, because if you think about it, if you're just going to make, say, 50 requests in a day, that's okay. But for EC2, you'll be actually having that server up and running the entire day. So you'll be paying for those 24 hours. So not all the time, it depends.
Okay, so yeah, again,
Yeah.
my answer would be it depends. Exactly.
Yeah.
Thanks, Kapil, for saying that. So yeah, it
Yeah.
depends. So don't consider that Lambda is always going to be cheaper or always serverless is cheaper. It purely depends on use case, because you may run a Lambda function millions of time in a day and you end up paying more than an EC2
Right.
machine. So just be aware about that factor. Great.
Yeah.
Now,
And there are a lot of factors, Ashish, in the pricing of Lambda. So in Lambda, the pricing depends upon the duration for which the Lambda runs, and also the amount of memory that you allocate to your Lambda function. Okay. So plus the number of requests. So all these factors come in, and then the costing is determined. So it's not always the cheaper option. Like we said, it depends. Right.
okay.
So yeah.
Makes sense, makes sense. And can you give me some example of what you are showing on the screen? What is this? There are so many boxes and colorful icons there.
Right. So this is just to show you, like, when we think of serverless, we only think about Lambda, but actually there are a whole lot of other services. The main service I heard you talking about, S3. S3 is also serverless, folks. So remember that you are not managing those infrastructure. There's API gateway, there's DynamoDB, step functions, SNS, SQS. So using all these services, you can create a loosely coupled architecture. You can create a microservice based architecture. And the most of common use of serverless is for creating event driven architecture, which I'll talk
I
to you
want to
about
stop you
shortly.
there, Parna. I have a
Yeah.
confusion here. So let's say I have a application in which service A talks to service B.
Yes.
Would I call it loosely coupled architecture always?
So in case of a loosely coupled architecture, you're basically breaking down the application into smaller services, which are not really directly dependent on each other. The functioning of one or the scaling of one is not dependent on the other. They could be loosely coupled in the sense that, say, service one is sending out event, right? Service one doesn't really care what service two does. Service two is waiting on that event. So they are asynchronous communication happening. So when you
Okay,
have like a synchronous communication, service A is actually waiting for that response. Okay. It's like a blocking event. Okay. So that's not really what happens in case of a event driven architecture. Here, when we say loosely coupled, each of them can independently scale, each of them can be independently be deployed. So in that sense, we call them loosely coupled. Does that make
okay.
sense?
Yeah, makes sense. And I have a
Yeah.
confusion between what you would call a synchronous versus asynchronous. So if you could explain me
Okay.
that.
Sure. So I'll come to that. Let me just give you a little overview about, firstly, what exactly is Lambda. Okay. So since Lambda is one of the core components of a serverless application, so what we have is a Lambda function. That's your code. Right. So as I said, it makes life easier for you, for the developers. They just have to focus on writing their code, and you can write your code in any of these supported languages, or you can even bring in your custom runtime. Now, I kept on saying event driven, event driven. So Lambda always has an event source. Now, this event source can be of three types. So that's where the asynchronous and synchronous part comes in. So let me show you the different types in ways that a Lambda can be invoked. So when I say synchronous, synchronous meaning is it's like a request response kind of
Can I
action.
stop you? What do you mean by
Yes.
invoke?
So when I'm invoking, basically one service is calling Lambda. Okay, so you are actually calling a function. So if you see over here, a Lambda function typically comprises of this. Okay, so you are hitting the Lambda service API. Okay, the runtime API, as you can see over here. Okay, and there is a runtime that you've specified when you've coded your Lambda function. That could be, say, in JavaScript, Python, Java, etc. this is the code that you've written. Okay, so when I'm invoking, actually I'm passing or I'm calling this function over here, okay, which is called as the handler function, right?
Mm-hmm.
And in so this entire thing, if you go to see this, the code, plus if there are any additional libraries that you're packing them together, those are called as layers. That entire thing makes up your lambda function or your lambda application. So this part is where I'm invoking it. So I'm invoking
Invoke
it, I'm
means you're
calling the
calling that
function.
function, if I say in a very
Yes,
basic language. Okay.
yes, yes.
And
And
do I have to manually invoke this function? Okay, no, you have methods here, right? These are
yeah,
the methods of
yeah,
invocation.
these are
Mm-hmm.
the three ways, or the three ways of invoking, like I said, or calling a lambda function. So the first way is your synchronous way. So some of the services which can synchronously invoke your lambda would be, say, via your application load balancer. As you know, the targets of an application load balancer can be lambda, it could be an EC2 instance, it could be an HTTP endpoint. You could have a lambda sitting behind your API. You've
Mm-hmm.
created a REST API or a HTTP API, so it could be sitting behind a API gateway. And these days, you have lambda function URLs. It could be that also. So synchronous in the sense, once the request or the call is made to the lambda function, it is waiting on it. So, for example, in case of API gateway, it needs to, there is a timeout of 29 seconds. So under 30 seconds, it's expecting a response, so it's waiting for the response to come back. So it's like a blocking action. So that's what I mean by synchronous. However, there are other ways of invoking. Okay. So, Ashish, like you asked about synchronous, there are other ways also. There's asynchronous. So, for
Mm-hmm.
example, one of the use cases I was telling you about, data processing. So, we can do file processing also. Say you went and uploaded a file onto S3 bucket, right? And the next step that you would want to do it, you would probably want to transform an image. Maybe you've uploaded, you convert it to a thumbnail, or you want to go and process the data which is there in the object, or you want to transcode a video, etc. So as soon as that action happens, I want S3 to go and trigger or invoke a lambda function. So in a asynchronous event, what happens is, as soon as a S3 event has happened, so you can choose the kind of events also, not only just object creation, it could be object deletion or modification also, you can pick and choose. What happens is this event goes into an internal queue. Okay, so the lambda service maintains an internal queue, and it immediately responds back. It gives an acknowledgement that yes, I have received the message. That doesn't really mean that lambda function has run. Okay, it's just maintaining that queue. So what happens is your S3 function has immediately got a response, it's not waiting on it. That's called as asynchronous event. And in the back end, your lambda function will try and process the event. There are some built-in retries also, up to 2 times it will try to process it. Okay, so this is called as asynchronous events. And then there is a third kind also, where in case there are queues or there are streams, okay, real-time data streams, say Kinesis data streams or your Kafka, or say your DynamoDB streams, or even your SQS. Okay, so that's a queue. So what lambda service does is, it has multiple polars, as we say. It's going to go and collect a batch of events from these streams. Okay, they batch it up together. Say you can specify the batch window, you can specify the duration for it to wait to fill up that batch. And once it's collected it in a batch, it will synchronously then call the function. Okay, so this is a synchronous call, and it will keep trying to process all the messages within that batch. Of course, things can fail, as you know. So in both these cases, there is a retry mechanism here. Like I told you, it will do it up to 2 times. Here also there are some mechanisms, but in case it fails to process, then you can have something like dead letter queues, or you can
Mm-hmm.
have something called as lambda destinations, right? So obviously you want to keep track of what could not get processed, so you can do that in both these. You can have dead letter queues in both these places. But remember, in synchronous, how was it different is, the client has to handle the retries, right? So say
Okay.
there was a timeout, so the retry has to be done, the planning has to be done in your client application. Okay, So that's
I
the
have
difference.
one
Hope that
question
makes
here.
sense. Yeah.
I have one question. In the second section, which you said asynchronous event, and you gave an example of a file being uploaded into S3. So let's
Yeah.
say I uploaded a file into S3 and there was a problem in the Lambda service behind the scene, which was supposed
Yeah.
to process. Would it also fail my file upload?
No,
No.
that will not, because it's not really connected. So S3 is just
Okay.
going to
It's not
notify the
directly
Lambda.
connected. That's what you
Yeah.
mean by decoupled, I guess, right?
Yes, decoupled. That's what I mean. So, for example, if you see over here, I have S3 bucket over here. Okay, so I hope you can see my screen. So, I have a bucket
Yeah.
over here, and there is a event notification which has been set up over here. Okay, so what this means is, as soon as for any kind of events which is going to happen, it's going to trigger this Lambda. Similarly, if I open up this Lambda function also, you will see. Okay, so S3 is your event source, and you'll see in the permissions also. Let me show you something over here. Okay, uh, if you see here, okay, I'll open up the permissions. Okay, S3 has permissions to invoke it. So when I was telling you it will invoke it, you can see over here.
I'm confused here. So is
Okay.
S3 having permission to invoke Lambda or Lambda has permission to talk to S3? How is it?
Okay, so if you see over here, okay, this is a role, this is a permission. Let me take you back
Okay,
over
there is
here.
a role
Okay,
coming up. Okay.
yeah, yeah. So
So
this
Lambda
is
is assuming that role and going and talking and getting data from S3. That's what is happening, I
absolutely.
guess.
So over here, if you see, there are permissions. This is called as an execution role. Okay, so over here, it's a list of the permissions that Lambda has to talk to other services. Okay, so it is one of the service you're seeing over here is it has permissions to go and put the logs into CloudWallet. The other one is to talk to S3. And if you see what permission it has on S3, it has the permission to
Get
get
object
the,
only.
so read that object which got uploaded. Okay, so that was what I was showing you here. These are the permissions.
Okay, I have one
Make
more
sense?
question here.
Yeah.
Let's say I have uploaded 10 objects. So would this Lambda function process those 10 objects in one single Lambda or would it be 10 Lambda triggered?
Okay, that's a very good question. So that brings me to the life cycle of a Lambda. Let me just explain to you
Okay.
what the life cycle for Lambda function or a Lambda runtime environment is like. Okay, so firstly, what is the technology under the hood? So every time you're triggering a Lambda function, under the hood there's a micro VM. It is based on a technology called Firecracker technology that is created based on the runtime that you've selected. So every time you're triggering it, a runtime is getting created. Okay, now what exactly happens behind the scenes? Let me show you the life cycle. So obviously there are different ways in which you can go and deploy a Lambda function. You can upload your application zip package, or you can containerize it as well. So assume that you have packaged it up as an application zip file. Once you upload it, behind the scenes, which you don't realize, there is some bucket somewhere which is managed by AWS where your code is residing. Okay, so as soon as you are triggering the Lambda service, what exactly is happening behind the scene is this code gets downloaded. Okay, so there's some time that it takes to download that code. After that, your micro VM environment it gets created. That's called as your execution environment. Okay, this is still initialization. Okay, your business logic has still not run yet. Okay, that happens. After that, once this is done, the bootstrapping part is done, then your actual
I'm
application
confused here,
logic.
Parna.
Yeah,
Sorry, I'm interrupting.
yeah,
Why we need bootstrapping? Isn't there is already a container running? What is the use case of bootstrapping here?
yeah. So like I said, you there is not a container running all the time. Okay, so only when you
Okay.
trigger a Lambda, that's when it's going to be created. So that is where, if you've heard about cold start times, right? So that is not really a productive time for you, because there will be some time required to actually download that code, create that environment, and then run your Lambda code in it, right? So this is the part which actually matters to you. this part, the first time when the environment gets created, there's an initialization time which is involved, right? But you do not get billed for that initialization time, you get billed only for the time that your handler code is running. So that part you need to be clear. Now, next time there is an invocation, so your question was, if I have 10 invocation, what happens? Okay, now after the first invocation is over, it doesn't mean that that environment has been shut down. It waits for a certain amount of time. There is no specific SLA that I can tell you about, or a number, but it does remain warmed up for a certain amount of time. When I say warmed up, it means the initialization part won't happen again. Okay, so for the next request, it can directly go and run that code. So it will wait, and the subsequent invocations also can happen in the same run. Okay, so that is possible. Now, let me tell you another scenario now. Let me take you here. Okay, which is called as lambda concurrency. Okay, now under what condition will we have multiple runtime environments created? Okay, so the first time, as I told you, that's going to be a initialization which you're not getting billed for, by the way, and then the actual execution. Okay, this is the first request that comes in. So at this point of time, the t1 point of time, your concurrency is one. There's only one execution. Okay, now at t2 also, if you see, your lambda is still running, still your concurrency is one. Thereafter,
So
say there was
concurrency means basically parallel running lambdas. That's I can think of from layman definition.
a parallel execution environments where your lambda is
Parallel
going to run.
execution environment. Okay.
Yes. Okay. Now say the second invocation has come in. Now your first environment is busy, right? It is not free. So what will happen is another new runtime environment has to be created. So that's why you see the initialization again, right? Another invocation came in. Again, the first two are busy. Okay, so you have to create another environment. So hence, if you see at this point of time at t1, now the concurrency is 3, because there's 1, 2 and 3 environments there. At t2 also, all 3 are busy, so you see 3. Now think about it in this case. At t3 point of time, the first one is completed. Okay, this is done, this is done and over. However, in the meantime, there's the fourth or a fifth invocation that has come in. Okay, so currently how many are there? One. So this is done. One, two, three, and four. So over here, the concurrency is 4. Okay, hope that is making sense. And then finally,
So I
yeah,
pay for concurrency or no? I pay
yes.
for only lambda.
So let me show you about the calculation part now.
Okay.
Okay, so when you calculate concurrency, concurrency is on the basis of the number of requests coming in and the duration in seconds for which your lambda is running. So that is also important. Like I told you, the duration for which the lambda runs is also dependent upon the memory that you allocate. So by default, when you create a lambda function, you'll see that the default memory that is allocated is 128 MB. There is no way in which you can allocate the amount of CPU. So as much as memory you allocate, proportionate amount of CPU will be allocated to you. The more memory you allocate, obviously the task will run faster, so you'll see your duration will drop. Okay, but there is a fine balance between how much memory you allocate, because remember, memory is also expensive,
Yeah, there is a
right?
cost on that. I agree.
There's a cost on that as well. So as you see over here, long running functions require more concurrency, because if you look at the previous case, or let me show you here. Okay, the longer it runs for, the following invocations do not have a free environment for it to run in, right? So again, there's going to be more environments which have to be spun up, because these are long running ones. However, if I show you a short running one, now look at this situation here, where you have a short running lambda. Because it's short running, it's completing faster, right? So in this case, at the same point of time, you can see your concurrency is still 1. But in the previous case, because it was long
Yeah,
running, you can
long
see
running
over here,
function.
there are 4 and 5 concurrency at both these point of time. Does that make sense?
Makes sense. I have one more question here from the
Yeah.
security. So the firecracker machine which you are launching, the micro VM you are launching, do I get a dedicated host for that, or is it running on a shared environment with other customers also?
Um, I will probably need to get back to you on that one. Let me just check up and come back to you. Is that all
No
right?
worries, makes sense.
Yeah.
And can so if I'm executing something in one Lambda and it is in a micro VM, and if I launch another micro VM, can these two Lambda communicate somehow, or I need to create a mechanism from outside of Lambda service?
No, they cannot. They cannot communicate. They are both isolated from each other. So when,
Okay.
as a good coding practice, when you code your lambdas, you have to code them in a stateless fashion. You cannot
Mm-hmm.
assume that an environment that one lambda is running in, probably it's written some files in its temporary storage, that the other one will also be able to see that. It may not be the case. So if you want to actually persist some data and you want that data to be accessible by multiple lambdas, then you need to persist it to an external storage like an S3 or a EFS or a RDS or a DynamoDB. So they do not really share. And so it may run in the same environment, they may not. Okay, so yeah, so they are isolated.
And so, do I get a CPU control? Like you said, you just get control to memory. So, if I have a requirement, let's say I need 4 CPU to run my function,
Hmm.
how I would control it, because I do not have a knob to switch in or tune in.
So that you'll have to control via the amount of memory you allocate,
Ah,
right?
okay, so you
So,
proportionately allocate the CPU
yes.
based on the memory you specify.
Correct. So you can see over here the default is 128 MB. It can go up
Mm-hmm.
to 10 GB. So 10 GB is almost equivalent to 6 vCPUs. Okay.
6
So
vCPU, okay.
yes. So you cannot directly go and allocate the CPU power, but you can tweak your memory, and there are some tools called as power tuner tools which you can use. So you get a fine balance between the performance you require and the pricing which is just right for you. As I said, memory is expensive. It might bring down the duration for which the Lambda runs, but your cost might go up as well. Yeah. So this is the way you can control the CPU if that's what
And
your
how
question
about
is.
network?
Yeah.
Do I get a control of I need 1 Gbps throughput or 10 Gbps, or is it also controlled by the memory allocated?
Uh, Network, probably I'll have to check on that as well. Let
Yeah,
me
but
let me
there is
get
no
back to you.
setting
Yeah.
here where I can say I need 2 network card or 3 network card, right? There is nothing like that.
You mean you want to talk to resources within a
No,
VPC?
no, I want to ensure that I have a very specific bandwidth always available for my Lambda function in terms of network. So, do I get control on how much speed I can
uh,
provide?
Not really. The throughput, you don't really have a control on that. So proportionately, as your lambda scales, the throughput will also scale along with that. But there
Okay,
is
makes
no,
sense. So,
I
yeah,
believe,
proportionately,
yeah,
memory and network card would be allocated
yes,
based on, sorry, CPU and network would be allocated based on the memory you configure on that.
correct. Yeah. So there's no, I believe there's no direct way, but probably I'll check back on that as well.
And
Uh,
I do not pay for cold start as a customer because that is your thing, right?
yes.
Why I
Yeah.
should pay for it?
Right. So, for example, let me show you. Say, I'm just going
I
to
like Hello
test
World.
this function. Always helps, right? So, say I'm just running this, right? So, if I take you to the logs, okay. So here also you can see a lot of information. So you can see over here init duration. Okay. So obviously there was no runtime ready. There was no
Ah,
execution
okay, so this is
environment ready.
initialization duration. This is what you
Yes.
mean by cold start.
Yes, yes. And this is actually that you're built for to the close, it's rounded up to
Okay.
the closest millisecond, right? So these are the logs, and these are the Lambda service logs. This is not your application. Only this portion is your application log. These parts are generated by your system logs. Okay, so you can see a lot of information over here. You can see the duration, you can see the build duration, okay, how much of memory was actually used, and for your initialization how much time you took is this. Now if I try to test it one more time,
Mm-hmm.
okay, So you'll let me take you to the logs. So you don't really have a control of when the environment will shut down. Okay, it just freezes and waits for more invocation. It waits for a certain amount of time. After that, it shuts down. Let's see over here. This is the latest logs. Okay, so this is my logs which were generated. Okay, and okay, I think it created a new environment. That's why there is a initialization time. That's why you can
Initialization
see it
happening.
initial
Yeah,
time.
I could
Yeah,
understand. So
if it would
probably
have
you
used, yeah.
started it into let's say a EC2 or a firecracker. Maybe
Hmm,
that firecracker had to go through a maintenance, or the
correct.
EC2 machine went into maintenance. So even within that 15-minute interval, I may still see initialization, and I guess that's why there is no SLA associated.
Right, right. Absolutely.
Good.
Yeah.
And I had one more question. So every invocation I'm doing, I am getting a request ID so that I can track it individually. That's what is
Yes.
happening.
Yes. So you can, there are ways in which you can monitor that too. So if you see in your configuration, okay, so if you want to trace every request, for example, you have monitoring services such as X-ray. Currently, it is disabled, but you can enable it. So if you have a highly complex system where your request is moving to a number of services, you can trace that, and there is a request ID, like you correctly said, using which you can trace it. So you can enable it from here. And basic logging, I just showed you. It was logging it to CloudWatch. So currently the log format is just plain text. If you want to change the format, you can go in here. So these days you can choose JSON also. The level of application logs, you can choose that, but remember, if you choose a more
Okay.
granular level, it will cost you more. System logs are the ones which I showed you, the start, the report. Those are system generated logs, so you have control over that. And for example, generally for every Lambda function, there's a separate log group that is created. But say you want to aggregate all of them into one group, so you can create a custom one. Else there's going to be a default one which will be created. So you can do all this for your monitoring and tracing purposes as well. Yeah.
And what if I had to trigger one lambda invoking another lambda? Would it still be called a stateless architecture, or would it still be a decoupled architecture? Lambda 1 talking to lambda 2?
That's called as lambda chaining. It's not really recommended, but if you have like some kind of workflow that you want to create, where you want multiple lambda functions to run, entire workflow, you want to orchestrate it, then you can make use of step functions for that. It is not a very
Okay.
good idea for one lambda to call another. A better way of doing would be, say, if you have like a buffering in between the two lambdas, if you put a queue in between, I would say that
Otherwise, it
would
will
be
still become a tightly coupled architecture.
correct.
I agree
Yes.
on that.
Yeah.
Makes sense. And how about the file system access? Can I have my Lambda access some file system if I need it?
Yes, you can do that. Okay, so you can go and talk to, you'll have to configure a file system. Say you want to talk to EFS, you can do that too. Right, so now
Makes
it's
sense.
obviously going to talk to it via the VPC. So in when you'll have to connect your lambda to your VPC, where you say your VPC based resources reside. So you'll have to go and configure it. And when you do that, basically internally there are some ENIs created. Let me try and show that to you. Okay, so
You're
your
talking about
VPC,
network interfaces? Okay.
yes, yes, elastic network. So when I want to talk to a VPC based resource, obviously I'll have my lambdas do not reside in my VPC or your VPCs. It resides in the AWS's lambda VPC. So some ENIs are created via which it communicates to your resources which reside within the VPC. And these ENIs, just like you have security groups in your EC2 instances, you can set up your security groups here as well. Make
Okay,
sense?
good. Makes
Yeah.
sense. Okay, good. Thank you. So that is Lambda. What other services I can use in a serverless fashion? Is it only Lambda function, or you talked about
Okay.
S3 also? What
Okay.
else?
So Sure. So we have some common architectures. Like I said, we have one API driven architecture where it's very common to have a Lambda behind an API, and you'll have either you'll have a REST API or a GraphQL API. This is one way you can do things. The other way is through event driven architecture. So you can see this is an example where you have a service called as Event Bridge. So
Mm-hmm.
event bridge is like a router, you can say a event router sitting in between. It captures events from either your AWS resources, or it could be capturing events from your custom applications or from third party. So it just captures events, and you can set up some rules on the event bridge, so it will filter based on those rules, and if there is a match on a rule, then downstream it could trigger of a lambda, for example. So that is also quite a common type of architecture. This is called as event driven architecture. So let me just tell you. So when you have a event driven architecture, there are typical components in them. So you have a producer. Okay, the producer of a event, the producer of a event could be anything. Like I said, it could be a custom application. Also, it could be a SNS, simple notification service, which is producing a event or a message. You have a consumer who's going to read from it, and there's going to be a broker sitting in between, a event broker, which is doing that exchange. So this event broker can be of different types. So one
Mm-hmm.
example I gave you was your event bridge, right? That could be one type of event broker. Okay, and that is a push based, meaning the producers pushing the messages or the events. And there are other types also, as you can see over here, that is pull based, or sometimes they are also called as pole based. Okay, so where say your lambda could be reading from a queue, or it is reading from a stream, right, like a kinesis data stream. So these are the types of event brokers. Okay, so and finally, the types of AWS services that form your event driven architecture, these are the four common ones that you'll see. There are many others also. There is SQS, SNS, Event Bridge, step functions. So, do you have any specific questions with respect to these?
Yeah, I have a question like can so let me explain my understanding and correct
Hmm.
me if I'm wrong. So let's say I'm talking about event driven. So a customer comes to a point of sales and then he or she makes a credit card transaction. Should I call it as an event?
Yeah, so for example, they've made a credit card transaction and you've got a notification on your mobile, right? So
Mm-hmm.
that push notification or a SMS that you're getting, say it's coming from a SNS service. So that's also event driven. You've made a payment, and behind the scenes there is a notification that comes out to you. Yes, that is event
Okay.
driven, right?
And probably when I'm making the transaction behind the scene, a fraud detection is happening, a balance check is happening, a
A lot
notification or
of things.
credit check is happening. So that is how event triggered multiple things if needed. So
Correct.
I agree. Means that can be one event may manifest into multiple event behind the scene being triggered, and we need some
Correct.
mechanism to broker those event. I
Right. So
agree
there are
on that.
multiple observers for that event. Okay. So say a person purchased something on a e-commerce site. Behind the scene, there'll be multiple observers who are looking out for that
Observers.
purchase
Okay.
made. So there'll be one which will do the fulfillment, the one which will update the inventory. There'll be a
Mm-hmm.
third one which will probably send out email confirmation. So they are looking out for an event. So they are observing it. Okay, and in order to get that event to those observers, I will say there has to be some routing mechanism, and that's where you can use things like SQSQ in between as well,
Okay.
or say even event bridge for that matter.
Now, I may start with Lambda, but can I have my Lambda talk to any traditional services like EC2 or maybe EFS file system, a traditional service? So, can serverless and server oriented both can be connected together?
um why not? Because you can just within your lambda function, you can talk
Mm-hmm.
to any service, right? So all
Makes
you have
sense.
to do is create a service client, what we say in terms of developer language, a service client, and then you can talk to it. Obviously the lambda needs to have permissions for it. So for example, if you see here, I have a lambda which talks to DynamoDB. Okay, let me show you an example. So in this case, it's talking to another serverless service like DynamoDB, but just to show you how the communication is happening. So if you see over here, in front of the Lambda, there is a
Oh,
API
there is
gateway.
a
It's a
API
REST
gateway.
API. And the Lambda, so the API gateway actually has permissions to invoke that Lambda. So let me show you that also. If you see here,
Okay, so
okay.
this
So
lambda
you
is
can
considered
see,
as a resource and it is protected by a resource policy also.
right. So if you can see over here, the API gateway service is allowed to invoke this Lambda, right? Okay. So you can see that. So it's a resource based policy. This is different from the previous one which I was showing you, that was execution. So what's happening over here is the Lambda can be invoked by the API gateway. This is what it means. That Lambda
Makes sense.
in turn is talking to a DynamoDB. Okay, so over here now you'll see that it's talking to a DynamoDB service. So this is
Uh,
your execution role. This is different. The previous one that I was showing you, okay, so this was invocation permissions, and this is execution role. So it's able to talk to DynamoDB, and like you said, can it talk to any service? Yes, so long as you are using the service client in your code. Okay, so this is in Python. I hope you all can see it. You just need a service client. Okay, so here it's talking to a DynamoDB client, and that's how it's talking to it, provided it has the permission. And I showed you it has permission, so it's able to
so
talk to it.
basically, it is code, and if I can invoke a service from code, it could be through Lambda or independently, doesn't matter. I could
Yeah,
actually talk to even on-prem services too because I'm
yeah,
just writing a code or making a API call. Makes
correct.
sense, makes
That's right.
sense. And am I limited only for Python or Java, or can I have my own COBOL Pascal code running in that too?
You can have your own customer. So if it's a language that's not supported yet, you can have a custom runtime as well. So if it is one of the runtimes that's supported, then you just have to set up your runtime. I'll show you. You'll have to select it, or you need to include your runtime code within your application package as well.
Okay,
So
so
so that can
customization
be done.
can be done. Can be
Yes,
done.
that can be done. Plus,
Makes
as I said,
sense.
you can also have a container image. Okay, so it's
Okay,
based on the
container can
Lambda
also run.
base. Yeah, that's also. But there's a size limitation. The
Uh-huh.
container image size can go up to only 10 GB. So you
10
need
GB is
to
good
make
number,
sure
I
it.
guess. Yeah,
Yeah, yeah. If your requirements are larger, then probably you should use Fargate.
makes sense. Thank you so much, Parna.
Yeah.
I'm good. You have any other point to add for serverless?
I'll just probably show you some use cases of event driven architecture. So
Yep, that would make
one,
sense.
yeah, so one, this is a typical event driven architecture which you see in different industries, where you are uploading files to your S3 bucket, that is in turn is triggering a Lambda, and then it's doing something else in the backend. This is for file processing. Or where you have streaming data, right? You could have real time streaming data. As I said, it could be application logs, it could be click streams, it could be anything. So it's captured by, say, Kinesis, and your Lambda in turn is reading these messages in batches and then going and probably dumping it into some data source. This is another use case. Or a very famous one is the fan out pattern. Most of you must have heard about the fan out, where from SNS you can send out the message to multiple queues, and those queues can be read by multiple backend compute services, right? So this is also another example where, say, via your mobile application, you're hitting an API gateway, and the API gateway in turn is pushing a event to event bridge, and the event bridge is going and replicating the messages into three queues. Okay, and probably it is filtering it based on some detail of the event. Say status created goes into one queue, status processed, status refunded, so they go into three different queues. So it's fanning out. This is what it means. And anything which cannot get processed can go into a dead letter queue over here. So parallel processing is also happening. So there are multiple consumers here. So this is also a common pattern which is called as fan out pattern. So these are just couple of examples how you can build a event driven architecture. Hope that makes
Makes
sense.
sense. That's so informative. Thank you so much.
Sure,
All
Ashish.
right. So many questions, and thanks Kapil and Richard for answering these questions. Really interesting discussion. And now I was acting as a customer, and probably I have not given you tough time, Parna, and thank you for answering all the questions.
Thank you so
I
much,
just
Ashish.
realized that though I am acting as a customer, I am wearing a AWS t-shirt, so still like hopefully
Yeah,
everyone still understands. So let me
no
now
problem.
talk a little bit more from the analogy perspective, Parna, if you allow me. So
Yeah.
I'll quickly go ahead and explain some of the basic stuff to everyone. And maybe you need to take rest, so maybe yeah, switch off camera, have some water, and then we will again bring you back. So thank you. So let me give you a basic information that how Lambda actually works behind the scene, or high level information if I somebody have to provide it, that what happens here. So let's say I have a customer who is going to start something, let's say on a kiosk or on an airport check-in desk or wherever. So now for Lambda we need two type of things, or two components are main there, right? So first component, if you see here, the gray box is the service. So AWS maintains this Lambda service, and that Lambda service would have multiple servers who are capable to execute Java code, .NET code, Python, and so on. So there would be thousands and thousands of servers which are maintained by the Lambda service itself. Now, what I would do as a customer, I would create my Lambda function, which is where I would write my code. Whatever code I want to execute, Java, .NET, Python, or custom runtime, I would put that into my own code. That's what I'm seeing here. When this code would execute, so first thing, there would be an event which is triggered from front end. Could be a click of a button, could be an API call, could be somebody doing finger scan, or maybe an image detected into a camera, could be anything. And that's what we refer as a event which is happening, and that is where a trigger goes to the Lambda service. Now Lambda service will perform some basic check and identify, okay, you clicked button 1, so Lambda 1 has to be triggered. You clicked on button 2, so Lambda 2 has to be triggered. And do you have permission for that or not? So that verification is done by the Lambda service. It checks everything is fine or not, and then invokes a Lambda function behind the scene. So this is where we say, hey function, there is a call for you, go ahead, do your work and get executed. Now function is a code. That code needs CPU, it needs memory, it needs network connectivity, it needs the Java or .NET runtime. What we need in this case, we would be needing here a execution environment, and that is created by the Firecracker container. So let's say my code was in Python. So a Python Firecracker container would be created for me, or micro VM would be created for me, and then my code would be pushed into that container, into that micro VM, and it would start executing. So that is how we may have a cold start, because you woke up that container, hey start, it loads whatever required, and afterward you are going to bring in your code which will get executed. And if your code wants, it can go back and deliver result back to the customer and say your booking is done, or your reservation has been cancelled, or you have been upgraded to a business class, whatever you wanted. So this is how you may want to have a result given back, but it is completely optional. You may say, okay, I just accepted the request, I don't have to inform customer anything about it. So it's purely your business driven how you want to respond. Do you want to deliver result back to customer, or you want to deliver that result to a third service who would perform some any other operation on that? So this is on a very high level how Lambda functions actually work. Just be aware about some limits on that. There are no servers to manage. Millisecond you pay for. Automatic scaling, you don't worry about scaling, and it has rich ecosystem like Parna talked. It can talk to various services behind the scenes, CloudWatch, X-Ray, API Gateway, DynamoDB, multiple methods exist. Just be aware about limitation. So maximum is the 15-minute duration which is allowed for a Lambda function to be executed. If your code cannot execute in 15 minutes, maybe you have to break it into smaller pieces or use other services behind it. 10 GB of which is maximum RAM allocated, and it is all stateless execution, means whatever you store locally on that container is not going to be with you anymore. It would be removed as soon as it is terminated, and it may have a potential of cold start, but it has been improved. There is a feature which is called snap start. Check for that on documentation, and that is going to create a very fast Lambda function and reduce this cold start timing. So this is just some basic information about Lambda function. Now there were more question on what is example or analogy for a decoupled architecture. So let me explain about what a decoupled architecture may look like. Right? Sorry, synchronous and asynchronous processing. So see this one. So let's say you got a parcel delivery, and sometime if a parcel is important, what you may have, the parcel sender may have requested that you have to sign that receive, and then only the parcel would be delivered. Or let's say you got a passport being delivered to you, or you have a high costly item delivered to you. So in that case, what would be required, that you have to be present to receive that package. So this is synchronous, whereas sender and receiver both need to be present at the same time. Sender sends, receiver is not there, that communication is not going to happen because it is a synchronous communication. So you invoked something and it has to be present to process it right now. That is a synchronous communication. But consider you got a letterbox. So once you have a letterbox, a postman can come and drop letter into the letterbox, and you don't have to be present at home to receive it. It is staying into letterbox, it is logged with lock and key, and once you come home, you could open it and get whatever is inside. This is a simple example of asynchronous communication, where a sender and receiver both need not to be present at the same time. That is what we refer as a asynchronous communication. So hope that answers your question. Again, example. I'll talk about where to use step function. I'll talk about that in a minute. So you installed a letterbox, and once this letterbox is ready, a postman drops the letter in that, and then you, whenever get time, you go ahead and then remove those letters from there. Now it depends. I may go every hour and check the letters, or I may go every day and check it, or I may go in a week and check it. So it is up to me, but my letters are still stored into that letterbox. Nobody is stealing it, hopefully, and I can go anytime and receive it. That is what you mean by a decoupled architecture. So with decoupled interaction between a postman and a receiver, letterbox is solving that. This is how we are maintaining security and still having no contact between both of them and still getting the service delivered. Obviously, it will not work for everything. It may work for letters, but it may not work for, let's say you got a big delivery of vegetables. I don't want it to be left into my letterbox, so I may want to receive it myself. So that time I may need a synchronous communication. In other cases, I may use the asynchronous communication, should not be a problem. So how we create decoupled architecture in environment? See this example. Let's say I have a request coming in from route 53, which goes into my load balancer. Load balancer is sending request to my auto scaling group of web server, and then I have another load balancer who is sending request to my backend auto scaling group of application server, and we are now talking to databases. So what we did here, even if I am going to make any changes into my auto scaling group, I add new server or remove server, my route 53 does not need to make any update. It is just talking to the load balancer. So load balancer is receiving, it is decoupled my auto scaling group. I could keep on scaling out, scaling in, doesn't matter. And same way, my web server do not need to tightly talk to app server. They just talk to this load balancer, and behind the scene, it could be anything which is happening. I don't care at all on that. This is what a decoupled architecture is. But this is a synchronous processing, which means I need to have my app server always running, otherwise my request will be not accepted. So what I can do if I want it into happening into a asynchronous fashion, what I could do, maybe the backend I fear load balancer are replaced with a queue. So my request comes in, my customer sends me a order for buying some stuff. Maybe I am doing a maintenance on my backend who would process the order. I could hold those messages or orders into queue, and once my backend is ready, auto scaling group of application server is ready, I could then pick up those messages from the queue and start processing. So this is what we mean by asynchronous processing. So I hope this answers that what is synchronous, what is asynchronous, and what could be the use cases or services. So same architecture in synchronous fashion and same architecture into asynchronous fashion. Hopefully that gives you an example that how it actually works. All right, good. Now let me take a few more questions so that I can answer some of them. There was a question about step function. So let me talk about what a step function is, and probably I may have a demo also. So I will show you that simple demo also in case time permits. Give me a minute. Let me bring up that slide where I can talk about step functions. So step functions are useful when you have to execute your request into a specific format. And that time your step function can be really useful. Let's go ahead and talk about that step function, why I may want to use it, right? So lots of time it happens that we have to process our application in a sequence. Give me a minute, let me find that information so that I can go ahead and explain step functions. Sorry, just give me a minute. I'm not having that slide readily available here. I hope everyone is getting answers to the question, and if some questions remain unanswered, send them again and we would be happy to answer them. Should not be an issue. And I'm releasing those 1 minute question answer video. Hope you are watching them. Your question can also be addressed there. So if you have anything which you want to discuss, send it there and I would hopefully be able to answer it. There should not be a problem. Let me talk a little bit on step function and then I'll hand over to Kapil. So step function can be a really nice way when you have to combine all these architecture together. Let's see an example. If I'm talking about a business, let's say pizza delivery business, so there is a workflow or orchestration they are following. So maybe customer places an order, restaurant verifies the order that it is not by mistake they ordered 1,000 pizzas. If they still want to order 1,000 pizza, restaurant will check, can we deliver 1,000 pizzas in the time frame they asked? If I can, as a restaurant, I would move forward. If I cannot deliver 1,000 pizza at the same time, I would call and say, customer, sorry, we can't deliver you right now. So that's how the workflow is executing. Now, if you look here, there is independent tasks which we had to combine to create a workflow, and that is what we mean by orchestration, or maybe putting a workflow around it. So every business setting, as we see here, can be put together into a workflow. So can restaurant deliver the order? No. If yes, we move forward and notify the customer, notify the delivery person, order get delivered, and your food processing starts, right? Let's take an example of a bank. You are going to open a bank account, you fill up an application, that you provide documentation. Some document can be verified automatically, like you have able to verify your address from your document you provided. Maybe we were able to verify your identity from the passport or your driving license you provided. But in case something cannot be verified, then I may want to have a human review, and human would say, yes, I want to approve this application, or I want to disapprove that application, and based on that, approval or rejection will happen. So what is happening here, this is what we are providing as a mechanism. This is a business process, and if you have to put it into step function, this is how it would look like. What we done, we have created independent component, and these independent component are now being used to run in a workflow. And once I start, we would be getting verification of document and checking of address happening parallelly. If everything is fine, human review required? No, we approve the application. If not, we invoke a human review, wait for somebody to review it. If review approve happens, we would go ahead and say approve application. If human says no, this is not a valid example or valid document, I would go ahead and reject the application. So this is how a state machine looks like. Now let me quickly go into console and show it to you that how I could utilize a state machine if the need comes. So state machine is a really nice way where you can integrate multiple services together and put them into a orchestration or a workflow format, which we have seen, right? So here I am going to use some Lambda functions, but you could have used them with any other service, should not be an issue at all. It's a really interesting way to orchestrate your business function without about to create the full application on your own. So here I am on AWS console and I would go to, let's say, Northern Virginia, where I have created a state machine, and that's where I would show you a simple example. So my request is, I want to upload photos into an S3 bucket, and if that photo is a valid photo, I want to say yes, photo is approved. If not, then I would say no, photo is not approved, or I don't want to accept that photo. So what I am doing here, I have created a simple state machine here. This is rider photo processing. So I upload a photo. Here I am expecting that somebody would upload a human's photo. If they upload a photo of a building or a dog or cat, I want to disapprove it. So here is my definition. In this definition, if you look at the graphical interface, we have first Lambda function who perform face detection. If photo does not meet requirement, we end the workflow. If it is fine, we go ahead and check if the face has been already uploaded into our database. If not, then we do parallel processing. We add face to index, we generate a thumbnail, store it into S3 bucket, and then persist the metadata into DynamoDB. So this is what my workflow is, and this is the code who would execute it. And all these boxes are independent services. In my case, this is all Lambda function, but it could be anything at all, should not be a problem. You may have a EC2, a container, a Lambda, a DynamoDB, a SQSQ. It is up to you what services you want to bring it into Lambda function. And once it execute, you would be able to see how it is executing. So I am starting execution. I am intentionally giving it a wrong photo so that it would be creating an error for me, and then I will provide a valid photo to this state machine. So here I have, sorry, not this one. I am going to copy information from my bucket. I am issuing a photo information here. So I am saying, hey, process this photo which is with sunglasses. Okay, done. Let me start execution. So when I start execution, I would be able to see my state machine running. It starts with face detection. This is green, and see what happened. It has failed. It caught an error, and then it went into photo does not meet requirement, and my workflow ended. What happened? Let me check. So I provided this as an input to this Lambda function, which is a state machine component task, and then its output was that it detected photo in that, but it says looks like this photo is not a single person photo. It detected 7 faces into the photo. So what I am doing here, I am using a service called Amazon Recognition, and through that recognition service, we are analyzing the photos which are coming up. So if an invalid photo is uploaded, I say, hey, this is wrong and I don't want to go with that. But if somebody goes ahead and uploads a valid photo, my workflow would look little different for them to be processed. Let's go ahead and perform that simple execution, and then I'll hand it to Kapil for question answer. So here I have my happy face.jpg. I start execution, and this time see this, my green thing is face detection, everything looks fine, and if everything is okay, it went into different direction, perform this, and then persisting metadata done, and my workflow has ended. So this is how a step function helps you in orchestrating multiple components together and create a whole application or workflow if the need be. All right. Hope that answers, and get more question answers into the chat, and hopefully you are all enjoying and learning. And let me now hand over to Kapil. Kapil, you want to share screen so that I can add it into screen, and then we can have some question. Yep, I am adding it to stage. Sorry, give me a minute. Yeah. Yeah, if you can zoom in a little bit, that would be helpful, Kapil. If you can little bit more zoom in so we can cover the white space.
Let me try.
Yep.
Good enough?
Better. Much better.
Okay, so although I have shared my screen, we can like start reading the way we did last week. But I wanted to take a quick opinion of you guys. How many of you already working as a solution architect? Okay, I'll look wait for your responses in the chat. Meanwhile, we can start reading. We can take 1 minute to answer the first question. So I'll rely on Ashish to monitor the time. Let's go ahead. Okay, I think
Yeah,
most of
let's go
you
ahead with the
is
questions
getting
answer, Kapil.
right. So here the question is about the performance when you are talking about network latency and high throughput. When that is the key, then you should be like choosing the cluster placement. Why I included this question? Because it's important for the solution architect associate exam. You need to be thorough about different placement strategy, either it's cluster, partition, or spread. So I have included the link also. Please make sure that you, even though you have answered the question right, you understand the differences among all of these. So I'll move to the next question.
Kapil, if you could explain us like why some question is wrong, that would probably help a lot of
Oh,
people. So,
okay. Okay.
yeah, means for this we can start from here. Let's leave the first one. From second, we
Okay.
can
Okay.
say
Yeah.
that
Yeah.
why this subject may not be the right answer.
Yeah. Okay, I think most of you get it right. So here the question is about, first thing that question is asking that how you can query the data through the SQL in S3. Another thing is also required to visualize those in a dashboard. So if we look at the first option, Athena and QuickSight, so Athena will let you run a query in an S3 bucket, and QuickSight will able to help you visualizing the data in the QuickSight. So that looks like a correct option. I'll keep it in mind, and I'll move forward. Let's see the AWS Glue and Athena. That is second option. Glue will able to help you creating the tables against after the crawling the S3 bucket, but it will not allow you to run the queries. For that, you need to have Athena. So running the queries is not getting fulfilled here. That's why V is not most suitable. Same for Glue and QuickSight. Again, we need Athena to query that. So Glue is not doing that. Athena is just a visualization. So C is also not a right or optimal choice. If we think about the last one, Kinesis data stream and QuickSight. Again, data stream is something that allow you to ingest the data at a scale. It does not give you the possibility to query that. So that's where we need the combination of Athena to query and QuickSight to visualize. So option A is right. Yeah. So I'll move to the next one, and I also included some reference link. So it's not like just knowing the fact that how to use it, but try to go onto the link and try to experiment yourself. Try to like have some data in S3, build the glue tables, and run the Athena query on top of that. So I think the link that I have included, the blog post, is able to help you doing that.
Yeah, and we will include this document in the email, so you should be having access to this document, including the link. So feel free to experiment.
Let's go through the question number third. And while while we are going to do this, make sure that you are paying attention to Ashish's slide that he talked about decoupled architecture. I think that's a big hint when you are attempting this question. Okay, so here the question is saying that we need a scalable system that can take the inputs that is like coming from the television program and save it to the databases, RDS databases. And we need to think about like how we can do it efficient manner without downtime. So when you have tiled couple architecture, right, so you cannot guaranteed everything will go fine. There could be some like when the scale of the system is like number of inputs you get that you cannot handle and your system cannot scale. Either you are doing through the serverless or you are doing through the EC2 instances. Then when you are getting this architecture question, right, think about decoupled architecture first, serverless decoupled architecture and those things. So that's why I've included this question. So this question is not like how you will be scaling this, like how you can do a replacement of EC2 with the serverless, or how can you do the effective databases. Basically here the question is asking, or like the solution architect phenomena, to understand that can you decouple the this system. So if you take a look of the first option, migrate the front end to AWS, use the API gateway and route user to the request to the Lambda function. Yes, that can be a doable thing, but are we 100% sure that we can manage the scale? There is a limited concurrency capacity of the Lambda. So are we sure that we can handle that? So that's why it is not most optimal solution. Scale the databases horizontally and convert it to multi-AG. Again, we are talking about here the databases. The problem is not, so one problem can be a databases, but what about the compute layer? Then let's see what the third option is saying. Configure the front end and send the votes to the simple queue, SQS queue, provision worker instance to read the queue and write to the information to the databases. This looks like what Ashish explained, like decoupled architecture. So if particular system is not available because of any reason, then still you are able to manage and system can start processing once it's become live again. Let's read the fourth one. The event bridge can create the schedule event to reprovision the database, larger memory, optimize instance during the voting period when voting ends. And again, we are only talking about the database here. It is not talking about compute layer. So in this case, um, option C, where we are decoupling the architecture, SQS is the right. Why ask the question, who is working for the solution architect here? So even if you are like inspiring to be a solution architect or already working, if you are not getting habit into reading the white papers, I think it's right time to do that. And when you are making this kind of decision, like when to design the event or when to design the decoupled architecture, I have included one simple how to design microservices. That block, that white paper, you all should, I'll say, must read it. Let's go to question number 4, the final one. So here the question is asking a serverless mobile app that uses the API gateway, Lambda, Cognito, and DynamoDB, very popular architecture. During the large surge in traffic, users reported intermittent system failure. The API endpoint is returning HTTP status code 502. Here the like how will I approach it? You immediately think about which error code is coming from where. So as soon as I look at the 502, I should be immediately able to figure it out from where it's coming from. So if there is a like scaling problem at API gateway and it cannot take much more requests than it should, then that will give you the 4 to 9 throttling error. But here it's coming 502. That is something lambda error. So that's the mental model I should be able to build before going to the answers. So let's read out the answers. Increase the concurrency quota for the lambda function. Configure the CloudWatch to send the notification alerts when the concurrent execution metric approaches quota. I think it's most likely to be happen. So I'll go with A option, but let's keep it in a mind and read other options. Configure notification alert quota transaction per second API gateway at API. So when transaction per second is going above the threshold, then API gateway should give you 4 to 9 as explained before. Shared users in Cognito user pools in AWS region can reduce the user authentication latency. I don't think so. It is talking about the right thing here. Use DynamoDB from the strong consistent read. It is also not talking about the error that we are expecting. So after reading and applying our analogy or understanding, option A here uh, is right option. And again, I have included how to design a serverless multi-tier architecture. So if you read that blog, you will understand how to design system effectively around API gateway, Lambda, Cognito, and DynamoDB. Thank you, everyone.
That is great, Kapil. And yeah, question answer is a good way to check your understanding. And thanks for putting it and explaining it. And we will share this document so that you would get the best understanding of it. Now is the time for the weekly giveaway. Really sorry we have not able to select the winners for the last week, but we will do it sooner. So I'm going to paste a link into the chat that would be for the weekly giveaway so that we could go ahead and then select somebody who is willing to learn, willing to share, and we get you rewarded by either a book, which is a cloud career journey, or it could be one of the sandboxes we can win where you could practice and learn and then retain that knowledge for it. Remember, doing is important, otherwise you would learn it, you would think you know it, but unless you practice it, you would not be able to retain it. So hopefully this thing is clear. So please register. This is a link which I have put it into the chat, which would be available for you to get your free WizLab access or Cloud Career Journey book. And I also wanted to highlight that we will be having some people being selected for the 12th week giveaway who are been into the whole journey, helped us out, shared knowledge, supported us. We would be picking a few people for the premium plus subscription of WizLab, which would contain every single thing on the WizLab platform. So that should be good. And one more thing which I think Prasad would like to talk about is the group mentoring session we are going to discuss, which will be made available on, which is now available. So let me talk at Prasad, who talk a little bit on what these group mentoring sessions are. Maybe on mute, Prasad, so you may have to unmute.
Thanks, Ashish. Yes, I know we are almost on time. The group mentoring session is mainly for the Cloud Career Starter Kit community. And we are having the first session today at 3 p.m. GMT, that is 4 p.m. UK time. And the agenda is for the first 15 minutes, we will be talking about how to get best out of the starter kit, which includes your learning resources from Pluralsight, Wiz Labs, and other leading training institute. The second portion, which is the main session, will be a 45 minutes session that will be about how to create your own cloud learning path. And the last 30 minutes is a Q&A. We sent out a form to everyone who purchased the Cloud Career Journey Kit, and we got a lot of questions. So we are going to answer all those questions during the last 30 minutes. So that's the plan for the group mentoring session. So anyone who is looking to take advantage of Starter Kit, feel free to join the community. I'll paste the link here for everyone. That's all, Ashish. I'll keep it short.
Yeah, means it's interesting to have a lot of questions. A lot of interesting question came in, and we are looking forward to answer some of them as we get time. But thanks for sharing this, Prasad. And I'll now say goodbye. We are already 5 minutes extra, so let me add everyone who are helping us. Richard, so hope you get some more relaxed time and are able to come back to the routine. I know Greece was good, but now it is back to UK. So hopefully the weather stays good. And thanks, Varna. I hope I have not troubled you with so many questions and you enjoyed the conversation. I learned a lot, few things. So obviously it's a nice conversation. And thank you, Kapil, for putting this all together. And your support means a lot to us, everyone. And we want to be available on Saturdays, help you out. And once you shout out about BeSA program, or once you share that what you learned, it not only helps you in retaining that knowledge, it helps other also to being motivated. So keep doing that. If we can help you in your career journey anyhow, feel free to reach out. We can't answer every question, every thing cannot be done on a one-to-one basis, but we are trying our best to answer important question. If you have any, please put them forward, and we will see you all to the next week. Anything, any questions, any doubts, if you have, feel free to put them into LinkedIn group, and we would probably answer that there. Thank you so much. Have a good one. Thanks, everyone.